Hello, and welcome to the fourth session of the Civo Devops Bootcamp. You're joined once again by myself, Alistair, and Kai. Do you want to introduce yourself?
Yep, I'm Kai. I work at Civo. I'm a developer advocate / developer at Civo, and Alistair is one of our Civo ambassadors.
Absolutely, and you're probably getting bored of our faces if you've been watching from the start, because I think I've been in every one. Kai, you've done what, 3 now out of 4?
Yeah.
So you'll be glad to know you'll get a bit of a rest from us going forward. But yeah, this is the fourth session. We're going to be talking about one of the kind of core components of what people think about DevOps when they say DevOps or when they hire DevOps people or DevOps engineers, which is working on the release and deploy section of a DevOps environment, a Devops pipeline. So we're going to take a look through CI/CD, which we touched on last week. We're going to take a look through infrastructure as code and how those two things can tie together to build a really configurable and developer friendly pipeline. So can we bring my screen on? My share screen.
And while we're waiting for Alistair's screen, if you have any questions, just put them in the YouTube chat, and we will pick as many as we can to answer. Hello, Ahmed.
You can also tweet us. Things are underneath our faces, which will be cool. Yeah. So yeah, release and deploy. So I'm going to bring. We're going to talk about CI/CD pipelines. We're going to talk about infrastructure as code. So release and deploy. We're going to come back to the de facto DevOps kind of infinity symbol that you'll see all over the place. And you can see release and deploy here kind of in the middle. We touched on build and test last week, release and deploy now. And then I think as we move through the sections, we'll move around to operate and monitor. But yeah, release and deploy. A lot of the time, this means CI/CD pipelines. You've probably heard about those. Things running automatically when you add your code to version control, and things like that. We're going to step back a bit and take a look at the history of this kind of release and deploy section of the DevOps. I don't know what to call that simple DevOps thing. If you go back like 10, 5. Depends on your organization, right? DevOps is a journey, and all organizations will be at a different sort of stage on their journey. There's a company, who is it? Is it Datadog that do the State of DevOps report?
Yeah.
So they do this State of DevOps report every year, and it kind of takes a look at how mature organizations are on their DevOps journey. All the way from we're still running in data centers, manually provisioning machines and manually deploying software. So someone will give us the USB stick and we'll run down or we'll log in on the console and manually type a load of commands. All the way through to what we're going to show you in a little bit, automated stuff. But yeah, if you've got kind of manual deployments, I don't know if you've been doing any of these things, Kai, or have you moved straight into it relatively?
I mean, my first website would have sort of qualified exactly as that, which is I would log into an FTP server and physically upload files, that then would show up when somebody refreshed the website. So, that's about as manual as you get. But then obviously with more advanced web applications, there's more than just HTML files and pictures in there. So that's where the sort of environments and the fact that things need to talk to each other throughout the process come in. And that's where sort of you can't necessarily trust that you'll remember to do each step each time. But of course, like you were saying, it's a journey. So, a lot of people will have some parts of these in their organization still, and some parts of the things that we're going to talk about later.
Yeah, absolutely. And you mentioned there, like going through the steps that you need to deploy something. I've worked in organizations and teams who have 10-page deployment guides, which they'll hand out to someone at 4:00 in the morning, they'll start on bullet point number 1 and they'll just follow it line by line and do the production release. And if something goes wrong, they've then got to try and work out how to fix it, or there's no real clear way to roll back to the previous version and things like that. So there's nothing wrong with doing manual deployments. And like if you've got a little website yourself or a little web server at home that you're running on a Raspberry Pi or something, there's no problem with logging in, running a command to update it. The problem comes when you've got 10, 20, 50, 100 engineers, thousands of engineers in some organizations all trying to deploy a lot frequently. And it's kind of about, all of this is about reducing manual work, reducing repeatable steps.
Yeah, and as we said, if you haven't watched the first session, but definitely catch up on the previous sessions. DevOps is about speeding up the delivery of things that they bring you or your company value, right? So if you've got even 5 engineers who are all trying to deploy something and have to somehow coordinate, okay, like I'll do this and then you'll do that, that slows you down. I used to work in a company. I was not in a technical role there, but we would deploy once a week at 4 a.m. on a Tuesday, because that was the time that there would be fewest people actually accessing the website. So the head of tech there would have to wake up at 3 a.m. and sort of have his list of all the things that he would have to do and manually run those things. And if something went wrong, we would potentially have to wait a week to fix it, right? That's not sustainable if you're trying to rapidly deliver value.
And this is kind of the thing where the DevOps philosophy of automating the manual processes kind of makes the most sense. Because if you're doing manual releases at 4:00 in the morning, you're already tired. Mm-hmm. You've got bullet points to follow. You want to get back to bed or something, or you had a heavy night the night before, for those of you that might drink. But if you can automate the process and make all those steps, press a button, you've got confidence that if you run it again, it will do the same thing. You won't have missed a step. You can also run it more frequently because it takes no human interaction to do this. So that automation piece kind of fits in with the wanting to do things quicker, because if we automate them, we also have more confidence in them, which we talked about, was it last week?
Yeah, in the testing part. Because
so it's all
things that will tell you if they have performed the way that you expected them to.
Yeah. So if I've written my deployment pipeline, whatever it might look like, I know for a fact that it will run the same now, next week, in 10 weeks, and tomorrow. I can just run it and it will do the same thing. Confidence. I've got confidence to do it at any point, which means that I can do if I've got confidence that it's going to work, I can do my releases far more frequently. So instead of doing quarterly releases, which we've got at the bottom of the screen here, we can do weekly releases. And that would be a massive improvement. You'd be deploying 11 more times per quarter. So you can put in also, you can make smaller changes, and smaller changes have less of a chance to have a larger impact.
Yeah. Yeah, because if you're only ever changing something on your application once every 3 months, then you're going to be rushing some of those last minute changes in, just before deadline. And even if you're a really good coder, you might not anticipate some of those interactions between the different components, which means that you might actually be introducing something that will then be difficult to fix or to roll back. And
also, the fix will only come in 12 weeks. So If you do get it wrong, you either have to do an emergency release, which would cause chaos, or you've got to wait your 12 weeks. So if we break our 12 weekly release down into 12 one-weekly releases, they're all much smaller. You don't rush so much to get things in and therefore potentially introduce errors. And yeah, your customers also are getting value much, much earlier in that life cycle. They're potentially going to get new features every week, or updates or improvements, or that bug that they found that's really, really annoying them. You fix it within a week, they'll be really happy. And also, if you're in a competitive industry, or competitive environment, if you're releasing quarterly, you can bet all your competitors are going to be releasing much, much more frequently than that. And therefore their customers are going to get those new features, those bug fixes. And they're potentially going to be able to sort of chip away. Let's say you had a competitive advantage. They'd be able to chip away bit by bit, and you probably wouldn't notice it coming. They'd eventually just, because they can move that much quicker.
Yeah, it's about having the agility and having the ability to respond to business needs. That's ultimately driving this. Plus, of course, developer and operations team sanity. Like if you know that even if something goes wrong, it's a button press that you go back. It's a lot more a lot more likely that you're going to just try something, which is a really cool thing because that's where innovation happens.
And also, if you do still have a separate operations team who are responsible for running the application, they're going to be much more likely to say yes to your release if it's only a week's worth of work. And there's going to be far less paperwork.
Ideally. Yeah.
We'll talk about that in the future. And then this is a slide kind of looking at the future, or what I've called high maturity DevOps organizations. DevOps is a scale. Everyone sits on it somewhere. And just because you're not doing these things doesn't mean you don't have a strong DevOps culture. These are not indicative of we are DevOps, we're doing DevOps, but these are kind of some of the things that these high performance DevOps organizations do. So we've got automatic deployments. We've talked about this. You've got your scripts that run at a push of a button, at a commit or a merge into your default branch. I've also put in here short-lived automated environments. So one of the problems I've seen with less mature DevOps organizations is that they will create a single testing environment to test developers' new changes. And if you've got hundreds of developers, everyone's going to be fighting for some time on that environment. And also you can't ever be sure if it's going to be like your production environment. But if you can build short-lived environments automatically and either just put them in a different cloud computing account or create a different domain that your application is going to be deployed into, you can create one of these for every release, for every developer, for every commit, if you really wanted to take it that far.
And that's if you can. Just to go back to session 2, when we were talking about containerization, that's the sort of innovation that allows this to happen, because you can build a container on that includes the state of an application at whatever point. So every time, you could go as far as every commit that I make to this branch, build the container image, deploy it somewhere, and have me allow me to access it as if it was real. And that's the important thing, because in an ideal world, what you're testing on mirrors what reality is.
Yeah, absolutely. One of the things I say is a developer's code hasn't created any value for the organization until it's been tested on a production-like environment. And if we break that down, that kind of means if you've done a week's worth of development and code and you've never deployed it or tested it, it doesn't matter that you've done that, because you might throw it away. It might not work. It's provided no value to anyone because you're working in your own little world. But as soon as you've tested that on something that is exactly the same or very, very similar to your production environment, other people can then start basing their work off it if they want to. And you've actually provided value. You're moving towards this goal. So if you can do these automated environments and you can spin them up whenever you want, rather than having to wait for a slot, you can get to that point a lot quicker, and you can then pick up new work, and then you can, release that off into a real production environment.
And then if you can very quickly just show the Devops diagram again. I just would like to just jump on or maybe you were going to talk about that in the cross-functional team bit. But if you're looking at the release and deploy, which are kind of in the lighter green color from the middle and then to the sort of 1 o'clock position, those things, if you're able to create a deployment for a test feature and then give that to another team, say your sales team or whoever would be like sort of trying to get people to use that feature, you can then show them like, this is where we are. This is what it's going to look like. And they go, oh, I'm not sure about that, actually. You go, excellent. We didn't have to deploy this all the way into production to then for you to realize, oh, I don't like those colors after all, you know? So this kind of like, it's an immediate feedback thing. And there's sort of multiple layers of this monitor, plan, build, test, monitor, you know, happening all at the same time on different levels.
And that brings another interesting or useful point in. DevOps is kind of about bringing people together. It's about breaking down silos between not just developers and operations, which are the two words smashed together. It's about increasing collaboration in your company, in your, you know, environment. You know, if you can pass something on to the sales team, they can get really good feedback on it, and they can feed that back to you. You've increased collaboration there. You've shown them something. They're closer to the customers than you are, and they can give you guidance and feedback as to how you can make it better. So, you know, all these things help when providing value to the organization. Let's go forward. Cool. Yeah, and another point on here: cross-functional teams, which is kind of the dev and ops bit. The dev, you know, if you had your dev team and your ops team, there's already a wall here that you've got to kind of communicate across. But if you can get some of the more ops focused people and dev focused people on a team together, working on the same set of requirements, the same environments, the same everything, they're going to communicate and collaborate again a lot quicker, a lot better. And then, yeah, multiple deploys a day. We kind of touched on this. If you can make a deployment boring, then you're not going to be worried about doing it. A lot of the reasons companies give for not deploying frequently is they had a bad experience in the past. You know, I think a lot of us in the industry would have worked somewhere where, we only deploy twice a year because that one time it was a mistake and it was, you know, we took us a week to fix it and our customers were really unhappy.
And it took everybody back from holiday because, you know, it was so difficult to do. Yeah.
Yeah. But if you can make your releases boring and automatic, you should be starting to break down some of those potentially long held beliefs that deployments are bad and you should only do it once a year because of disruption. But if you can make it automatic, frequent, boring, you'll be well on your way to deploying multiple times a day, a week, a month. Just try and do it more often. And then you're better at stuff that you do frequently. You know, what's something you do every year, whatever it is, I'm not going to be very good at it. Something I do every year compared with something that I do 5 times a day.
Yeah.
Because you practiced at it. You get better at it the more you do it. So if you can deploy more often, you practiced, you can start to iron out some of those issues that you have and things just get easier. And then we'll move on to like the main bit. We mentioned this earlier, I think. A lot of people, when they think about DevOps or a DevOps engineer or the DevOps role within an organization, they think about someone who's going to build them a CI/CD pipeline. It's going to look after taking their code from the left-hand side, from code, all the way to the furthest thing in here, in the production sphere on the right. It's a big part of what we do, but it's not the be-all and end-all. I mean, DevOps isn't about just having a shiny CI/CD pipeline. You could have the best one in the world, but if people in your organization aren't communicating, you don't know what to release. You don't know, you don't get that feedback from your customers, from your sales team. So, but nevertheless, very important part of our journey. And it's about automating, like we've said, automating the boring stuff.
Exactly. Like this is the sort of technical side of the sort of DevOps culture. But it's still ultimately DevOps is about culture. And again, the things that we have, or Alistair has put on this graph, which has, the build and the unit tests and the integration tests and everything else. This isn't the manual of how to do it, right? Because every organization will be different. And moreover, there's more research being done all the time based on real world experience. So what you're going to get is people, you're going to have different things being slotted in, going like, actually, this is a really good practice to be doing at this part between your build and your unit tests. And then more and more people will start to do that. And that might not appear on sort of DevOps sort of graphs and instructions yet, but like this whole thing is a dynamic process. Just like companies who are moving into a DevOps culture are on a journey, DevOps itself is on a journey.
Yeah. And one kind of thing, I think it's been mentioned in questions in the past, is like security focus. So like DevSecOps, or shifting left, the terminology is, which is taking stuff that traditionally would have been done at the end of a release cycle, a build or something. So things like your security, like penetration testing, your audits, also testing traditionally, like you might have had a team of people who'd test on one of these long-lived environments. But if you can shift that stuff left, closer to the developer, builds your unit tests, and you scanning your container images for vulnerabilities and doing static code analysis and things like that. If you can shift those closer to the developer is going to be thinking more about the outcomes of those, and you're making it easier for the developer to almost do the right thing, but you're making it easier for the developer. You're giving them the tools they need to succeed, because all of these things in the whole software delivery lifecycle is everyone's responsibility. So you can't just say, oh, I'm a developer, I do features, I don't care about security. That would be a bad view to have on the world.
Yeah,
I don't care. Yeah.
Everything is potentially a security concern, right? And then sort of to go back to like deployment frequency is part of the thing. If you're deploying very frequently and you're making small iterative changes, then you know that if suddenly a security, an automated tool notifies you like, this has now been determined to be unsafe, you know exactly where that happened because it was in that last commit. It wasn't the thing that you may have done 3 months ago and only now deployed, right? So every time that you commit and you run these tests and sort of are ready to go into production with something, production being the real world running of your application, then you know that you're more likely to be secure.
Yes, we've just had a comment. So everyone in the team in DevOps and DevSecOps. So DevOps and DevSecOps, if you ask me, and again, it's my opinion, isn't a role that someone sits in. It's a organizational culture. It's a way of building and deploying software. So yeah, it's everyone's responsibility. Like everyone is involved in every part of the project, or they can be, or they should know about it, or they should be able to very easily find the person and ask them a question. It's about breaking down those walls. Another one as well is security tests under the unit tests or done at the end of the CI/CD pipeline. You can put anything. This isn't a definitive guide to CI/CD. This is just a few things plunked on the screen. Every organization will have a different interpretation of this, and you'll be at a different place. You'll have different concerns. So you can put that security testing wherever you like, really. You might have multiple types of security testing. Yeah. So we've mentioned static code analysis, and we've mentioned scanning container images, but you could also have automated vulnerability scanning against your staging environment, and you could run that after every release.
And you could have things as part of your unit tests. You could have, sort of making sure that you're sanitizing input of all forms. That would be kind of a unit test because you're testing that the function does what you're expecting it to do. But then you'll take those and couple that with other sort of more wide-ranging security aspects and be testing those sort of throughout. So yeah, like the answer is like it's yes and like it in an ideal world you'll be thinking about security throughout these tests and be including security oriented testing in in whichever part. There's another question that's come in. Which are the tools used in CI pipelines or in CD pipelines? We're going to talk about that later. So there's actually a section coming up about the tools that are used. But I know I'll probably say it in that section as well. These tools change all the time. There isn't a best one categorically. You will use whatever your organization happens to use, or you will try something new. You'll find that, oh, maybe actually like this could work better for us. It depends on your situation.
Yeah, choosing a particular set of tools won't make you the best at DevOps, but choosing the set of tools that most fits your kind of requirements, which might be price. You might want the cheapest thing. You might be just starting out, or it might be security integrations. It might be you use GitHub, so you're going to use GitHub's one. All of these tools can do all of the things. There's no limitation really. It's just they've all got slightly different feature sets and might fit in with your organizational culture, or they might integrate better with your existing tooling. So it's kind of a per customer, per business decision or question. Yeah, I can't sit here and categorically say one's better than the other. First of all, I haven't tried them all, but second of all, they all kind of do the same thing, but in a slightly different way.
And they're all sort of like, competing in the same space roughly. So one of them will come out with a feature that nobody else has in the newest version, and people will go, that's cool, and maybe move to using them. So like any advice that we give you about a particular tool today will probably be out of date in 2 months,
Yeah. So we've talked about CI/CD and pipelines, and we had a question on this last week as well. What is a pipeline? And we didn't really think of that or cover it, but I've put a slide in here. So my best kind of definition would be it's a set of steps executed in order. So think about like water going through a pipe. It flows from one end to the other. So your code, your commit will flow from one end of the pipeline to the other. A lot of the time, things before it have got to pass before it will move to the next stage. So say you had your unit tests. If your unit tests failed, you probably don't want to be releasing it because you've already determined that something isn't right with your code. So you just stop at that point. Partly because most of these tools cost money to run and time, but partly because you don't want to release something you already know is broken. A lot of the time they're configured as code, and what we mean by this is there'll be some like file which defines how each of these steps run and how they all fit together and what to do if they fail and stuff. And because they're configured as code, they can be peer reviewed. So if I suggested a change that I wanted to add a security scan, and I was working with Kai, he could have a look at it and say, oh, actually, I don't think you've got that quite right, or we might want to move where it's been put.
Exactly. Like we might go like, actually, it would be better if it was scanning it here because already these steps that are taken will take time. And this is a more important step, say, in terms of like, there's no point in us building a test database if we already know that there's an audit that needs to run on access to that database, right? So you can move it ahead because the previous steps have to pass for the future steps to run so that you get the most efficient way. So you're not waiting, because these things can take a long time to actually complete. And so you almost want because we were talking about fast feedback last week, and you want the fastest feedback you can going like, oh, it's broke, it's not passed. Here's the error message. This is what failed. You don't want to be waiting for hours for that.
Yeah. Absolutely. I've just thrown in some example steps, and we've talked about these quite a lot, but you can do kind of anything that your brain can imagine inside most of these sort of pipeline CI/CD tools. You can do everything. So the sky is the limit. You can, do anything. I don't really know if there's much to add there.
Yeah, just in terms of what you can do on your pipelines, you might want to add to them as your application gets more complex, right? So, if you're literally building a single function that runs in a container, you might not honestly need that many sort of scanning and sort of manual tests, because you'll prove that that single function works through your unit tests. So, you almost want to go with the minimum viable thing that you can trust.
Yeah. Start small. If you haven't got one and you want to create one, start with build. All right. Just see if your code build it into something, and then you can start to plug things in later when you get more comfortable with the solution, or when you get more requirements coming. Oh well, we want to run the unit tests in the pipeline. Okay, we'll put that in before build. But just start small. Start with something. There was a question popped on the screen of how are pipelines configured as code. There it is. Every tool will have its own way of building these pipelines. It can be as simple as like a script where you just write the commands you want to run, npm test, whatever it is, all the way through to like multi-level YAML files or JSON files or whatever that can define really, really complex environments. They can run in, you can even get pipelines that run each step inside a different Docker container. So you can almost your unit tests are going to need your programming language installed to run them. So you can choose a container that's got that. But for your deploy, you might need Docker installed if you're going to build a Docker image and deploy it up to Docker registry. So you can use a container that's already got Docker installed. So they can get really complicated. But again, start simple. If you haven't got one, get confidence in it and work out what's going to work for you. We will look at GitHub Actions. We've got some GitHub Actions configured, and we'll talk through how it kind of works and how you can get started on those.
And speaking of getting confidence, there is a quiz in the video description where you can test your knowledge after the end of this video. So Alistair and I, we came up with some questions we think are fun around this presentation, and thinking about what pipelines do is a good one to keep in mind for those questions.
Awesome. So we've kind of covered off the first part of our release and deploy. So we've worked out how we can release and technically how we can deploy something. But then I wanted to introduce the concept, which is infrastructure as code. And I put at the bottom, or systems as code, because it can be far more complicated than just your infrastructure. And for those of you that haven't, sorry, go on, Kai.
No, I was just going to say, just for a quick definition, I don't know if you were going to define what infrastructure in this case means, because I can do that quickly.
Yeah, go for it.
Yeah. So, if we're talking about cloud computing, infrastructure is your cloud resources. So what infrastructure as code means is defining in code, so in a software language, what resources, how much RAM, how many processors, what sort of configuration networking wise you're going to need on these virtual machines or on your Kubernetes cluster if you're doing Kubernetes, for your application to run, right? So instead of manually building a PC, and screwing a hard drive in, you kind of go, I would like 500 gigabytes. Thank you. And the system will then read that line and go, here you go.
Yeah. And the kind of rise of infrastructure as code has been mirrored with the rise of cloud computing as well, because a lot of the cloud providers originally provided a graphical user interface. On you go into a web browser, you'd log in, you could click buttons that would launch you a virtual machine, and you'd be emailed a password which you could log in on. But as cloud computing got more mature, the cloud providers have started to produce an API layer which you can interact with, using scripts without having to manually do stuff. And that has kind of led to the ability to write our infrastructure as code rather than, log in and I want a big database. You'd go, I want a database in your code exactly this size. And then you can apply the same principles that developers would with their code. You can put it in version control. You can peer review it. We can raise our pull requests. And Kai could tell me off if I wanted to create a 1,000 node cluster. He'd be like, it's my credit card on the account.
Yeah.
No.
Yeah. For your test run, which is going to take 5 minutes, we don't need 1,000 nodes. Like,
damn it! But I wanted to see what would happen. No, I mean, we're kind of, this is, potentially a big part of what a DevOps engineer or an infrastructure engineer or a platform engineer might end up doing. A lot of integrating and configuring systems using code rather than like manually, which used to happen. And the reason I wrote systems as code is because some of these infrastructure as code kind of tools, which we'll see here, can be extended to interact with anything that's got an API. So I've worked in an organization where they configured their own software with a Terraform provider. So they wrote their own Terraform provider, which allows you to configure, what you want, that ran against their own API after they'd installed it with Terraform. So it was like everything was done in infrastructure as code. They created their GitHub users with infrastructure as code. So everything was checked in at GitHub. Everything was peer reviewed. So there's no questions as to like, oh, Kai left the company. Did anyone delete his GitHub account? They'd log in, they'd create a pull request when the person left and they'd merge it and it would automatically remove Kai's permissions or his SSH keys or, so you can configure entire systems, entire organizations just automatically. And that also reduces our manual work that we've got to do, which was part of what we said DevOps kind of was, reducing manual stuff. There's a lot of things on the screen right now. It's probably best to just know there are many tools, as with CI/CD pipelines, to do infrastructure as code stuff. Some of them are better at certain parts of the, what's on the bottom, certain parts of the system than others. And you may need to use multiple of these to set things up.
And like that's the important thing is like some of these can hand off to other things. So you can have a tool that sort of say that you have a Terraform system that provisions your virtual machines, as in it reserves space with a cloud provider and says, I would like this amount of processing power and this and whatever. And then it hands off to something like, Chef, Puppet, or Ansible for the next step, and configuring the way that these things work together is a big part of kind of the domain knowledge of, the sort of infrastructure side of DevOps.
Yeah, exactly. We're going to go to like a demo. Yeah. And hopefully, unlike last time where I lost all mouse and sound and everything, hopefully everything will work. But we're going to have a look at some Terraform. So Terraform's my favorite because I use it. Doesn't mean it's the best. It's just the one that I'm the most comfortable with. So I don't know if you can read that very well, but we're going to jump to a different screen in a minute. But what we're going to do is we're going to deploy a Kubernetes cluster on Civo Cloud using our CI/CD pipeline. So we're going to raise a change. We'll probably change the number of nodes, maybe. I will raise a pull request, and then we will watch our sort of pipeline run through. We'll talk through the stages and why those kind of things might be interesting, and actually how you can quickly build up quite a complicated pipeline from lots of small steps. So it doesn't have to be this big daunting task all in one go. You can start with, right, I just want the very smallest thing and build on top of it. So if you can take that off, if I start, yeah, there we go. I'm going to try and share a different screen. Where is it?
I'll just plug the quiz again. If you are following the Civo DevOps Bootcamp, there is a quiz for every week. And this week's quiz is linked in the description. And then definitely tweet at us how many points you scored. It's always fun to hear what people think of the quiz.
Right, sharing my screen. Technical issues. Your browser has blocked your screen sharing. Oh no.
Oh no. You got it in a different browser or just a different window?
Oh, there we go. No, why is it not there? There it is. Allow. Right.
And this is why live demos are a pain.
Yes. Right. I will increase the size again. Thanks. How big? You can't see this, but I'm trying to change the font size.
Yeah. A couple of steps up will be good.
Kind of not letting me. Plus.
Can you do it with like Meta Plus or?
No.
No.
File. Please hold. Editor. Font. Here we are. 24. Oof,
Yay! That's better.
That's better. Okay. So this is Terraform code. It's called HCL, Hashi Config Language or something. Sorry if you actually know the name. It basically is used to define the state you want your system to be in.
Yeah.
So I've said I want declarative. I declare that I want a Kubernetes cluster here with 4 nodes in the New York region. And if I were to run this Terraform code, Terraform would go off and it would ask Civo Cloud, how many nodes are in the cluster at the moment? And if anything came back that wasn't 4, it would make a change, or it would say it was going to make a change for me to bring it in line with being 4. Hashi configuration language. There we go.
Thank you, Ahmed.
Yes. So you declare what you want, which is different to some of the other infrastructure as code languages, which are, what's the other one? Imperative? Can't remember what it is. But basically, they all run a set of steps over and over again. So if you say, I want 2 more nodes in your language, and you ran it twice, you'd end up with 4 more nodes, and it would do that. Whereas if with Terraform, it will try to bring the system in line with your configuration.
Which happens to be the same paradigm that Kubernetes uses. So obviously we haven't talked about Kubernetes on this course yet, but that's all declarative as well. You kind of go, I want to run, this many instances of this configuration of this container, and it will keep doing it until that system is achieved.
So there's a little bit of difference with imperative. Thank you. There's a little bit of a difference with Kubernetes, because Kubernetes will run that over and over and over again, and it will constantly be trying to get to that desired state. Whereas Terraform only takes these actions when you run it.
Yeah. So this only runs once and tries to get to it, whereas Kubernetes will run constantly and keep it at that state.
Yeah. So I've increased the number of nodes that I want to 6. Simple change. We've got more traffic coming, Kai, to our application. We need to increase the number of nodes to cope with it. So I've checked out a branch. I'm going to add my change. And I'm going to use, I can check this into version control. I'm going to give it a commit message so that future me and future Kai know why we made a change. Well, know that we made a change, and that's what we did. I could say increased load. So when we come back to it in 6 months, we go, oh, why did he change it to 6? That's costing us more money. Well, at the time we had more load or something. So I'll do that. And I will push that up to GitHub, and it's in GitHub. And I can now create you can't see this, but let's switch screens again. And hopefully it won't be as impossible as before. So I'm going to stop sharing and I'm going to share. Oh, can I share multiple screens? Oh, that might be cool.
I don't know if you can. I think it only let me share one at a time.
There we go. So if we can bring that back on, we've got like a magic helper in the background. Thank you. So I've raised I'm about to raise a pull request, and we can use our version control system to see that I've made a change from 4 to 6 nodes.
Can you create a pull request? That just slightly increase the size of your browser. Yes.
There we go. So I've raised a pull request, and we can see now that we've got a GitHub action, which is one of the CI/CD tools that you're able to use. And as we said, no one is better than any other, but this one is free for me to use because it's on GitHub. Oh, we can see that it's failed, which is fantastic.
Were you not expecting it to?
Well, we'll do what real software people do, and
which is
fail
really
over and over again.
Yeah.
Yeah. So, Terraform format. Okay, so yes, I meant to do that. No, I didn't. So I've written a pipeline here, and it's got, as you can see, it's got multiple steps. And this is what we talked about earlier on with that diagram that you start with your code and you end up with a deployment in production. So we can see that it's got to a certain step here, Terraform format, and it's exited. It's failed. It's failed my quality check because it's not been formatted, which is linting, I guess.
So that in specifically is something that you added in there to have because Terraform provides us with a formatting check to ensure that we have things in the correct format. That's not something that automatically just magically exists. That's a pipeline that you've defined, right, Alistair?
Yes. Yeah, we can take a look at that. So I've written it up here. So this is defining our pipeline as code. There's quite a lot going on.
You're still showing the other screen.
Oh, here we go. I can share more than one screen. Oh, no, I can't. No. Share screen. God. Why is everything so hard? That's the one. There we go. If we can bring that on, like magic. This is a definition of a pipeline in GitHub Actions. It uses YAML, which is a configuration language, I guess. It's a markup language, I think it is. And it's defined a job, which is a pipeline or a set of instructions in GitHub Actions, and it's called Terraform, or it's called Terraform with a capital. And we discussed earlier that you can get these to run on certain containers, certain base images or whatever. So this one's running on Ubuntu latest. So it's just saying run on whatever the latest Ubuntu is. And then steps is like our stages through our pipeline. This is how our code will flow through these steps. So you can nothing's happened at the beginning, and by the end we should have completed all of them. And you can see I check out the code. This is pretty common in GitHub Actions. Some of them it will do it for you. I'm setting up Terraform, which is the tool that we're using, and we've got a specific version. And we're also logging into Terraform Cloud, which we'll see in a minute. And then this is the stage that we failed on a minute ago. It runs Terraform format check, which will, if you can see at the bottom of the screen here, I've run Terraform format and it's changed these lines for me because it's opinionated and it says that you've got to have a certain number of spaces here. So
and the interesting thing here is that for you, it was set to, in this particular linter, was set to fail if the format didn't match. But there's, in fact, linters out there for various languages that will make that change for you and pass it afterwards. So it will actually go, okay, I didn't receive something in the format that I like, but I'm able to fix it because I know how. Save it, almost recommit that one, and then run your test.
Yeah. So I've added that, and hopefully I can see whether it's passed or not, and I won't get embarrassed if it doesn't. It's running. We'll just run through the other steps now while we've got this open. We run Terraform init, which is just something you've got to do in Terraform. We validate our Terraform configuration, which is different to linting it. Linting is about, is it got the right number of spaces and is it formatted correctly? Whereas validating is going to go and check. It's doing a bit more of an intrusive check that I've not done anything stupid. And then we run Terraform plan, which will hopefully tell us that we've tried to increase the number of nodes for our Kubernetes cluster. And you can see in here we've got an if, and this is conditionally going to run it when we've created a pull request. So it won't run when I've created a branch. It won't run on the default branch main. It will only run on a pull request. And then also I've got something here as well, which on a pull request will actually grab the outputs of all of these pipeline steps and comment that back onto the pull request. So hopefully it has passed. So I'm going to bring back the other screen. Give me a second. Whoop.
So effectively, kind of like the error, instead of the error messages, you're going to get the verification messages, but they'll come back on the pull request rather than just in that console.
Yeah. So instead of having to go and look somewhere in Actions to find out what happened, if I can bring the screen back on.
There we go.
There we go. And you can see here that the GitHub Actions bot has commented on the pull request, and our style was successful, which is great. And it validated and it planned, and we've actually got the output of the plan here. And you can see that it's going to update something. I also have some other bits and pieces in there. So there's a plan that's going to, no select annotations. Yeah. And it's, here we go. The Kubernetes cluster is going to be updated in place. It means the number of nodes from 4 to 6.
Yeah, exactly.
Yeah. So I also have in that file a deployment that deploys into the Kubernetes cluster. We might get to have a chance to look at that, but probably not. But yeah, we're going to increase the number of nodes. It hasn't run, it's just done a plan. And if I merge the pull request.
And this is where you would do in a sort of, possibly in a real world situation, you would tag somebody else in just to go like, am I okay to do this? This is what will happen. And that person will be able to go, okay, I can see exactly that the automated tests are fine. The change that will happen is the increase in nodes. And I am happy for this to go ahead. I will approve it, and then everybody can see that who's approved what and what the processes are, which in this case is applying that change.
Yeah, and so I'm using something called Terraform Cloud, which allows you to run Terraform remotely. So I've essentially in my pipeline, I've triggered an execution to happen somewhere else. I'm not actually running it here. And we're streaming the changes back to the console here. So what we can do with this, if we trigger that remotely, is we could even add a stage where we deployed to our staging environment, and we could add after that a set of automated tests that could run. And if those failed, we could stop the pipeline before it got to our production environment. So these things can be quite flexible. They can be complicated, but you can also keep them simple, like we said. Get started. Keep it simple. We actually, this is where this Terraform code is actually running. So we can see it's modifying the Civo Kubernetes cluster here. I think you can see that here, you can. And we can see the same output here.
And the reason you're doing that in Terraform Cloud is that, am I correct, is that's just simply because on GitHub Actions, you can't actually run, or in your particular GitHub action, you cannot run Terraform.
You can run Terraform. So we discussed how Terraform tries to reach a desired state. So if we had 4 nodes and it was told to go to 6, it stores its state. So it creates what's called a state file and stores that. If I ran it inside the action itself, I would have to work out where I was going to put that state file so that next time I run...
Because the action only exists while it's running.
Yeah.
Yeah. That makes sense.
I'm going to log in. Whereas Terraform Cloud manages that state for you, and we can probably have a look at it. So that's completed. So my cluster, if I log in a minute, should say you've got 6 nodes. But we can also see in here, we've got a series. These are the states that I was talking about. And we should be able to see here, we've got to change nodes 4 to 5. There's some change. These are very complicated. But we've saved that state, which we don't have to manually do ourselves if we do it in a GitHub action. So it kind of shows you can string together, you can grab multiple tools from multiple places, and you can build kind of a complicated pipeline, but without having to do all the hard work yourself, because I'm lazy. And
I think that's a very defining quality of a lot of specialists in sort of the DevOps field is I don't want to do this every time. I would like to have it done automatically for me.
Yeah, it's part of the DevOps philosophy, isn't it? Automate the boring stuff, automate the manual stuff. So being lazy, in inverted commas, or wanting to automate the boring stuff is kind of a good trait. If I can save time by automating it, I will, or save time by using a third-party tool. I don't have to build everything myself. I'm more than happy to lean on the work of other people. For some reason, we've got 5 nodes.
Is that because it's counting the control plane node as one of them?
Well, if it does, then that's a bug. No, I don't know.
That's probably something I should look into. Yeah,
that's very possible. But yeah, we've updated the number of nodes. It would be interesting we can actually run this again. So I can also run this outside of my pipeline if I want to as well. And what this will do is it will go, does the state that I've got match the state that the third-party provider is saying? And if the answer is no, it will take the actions. But I've not changed the code anywhere. All I'm doing is trying to get back to the state which I've already told it. So if I went and deleted that cluster, don't think we'll have time to do it, but if I went and deleted that cluster in the user interface and then reran the plan, Terraform would realize that I deleted it and it would recreate it. It'd say no cluster exists without ID. You need one, I'm going to make it. Yeah. Which we could do, but we've only got
a couple of minutes.
But you can see, okay, so 5, it's going to try and update from 5 to 6. And now it's waiting for me to confirm it. So if we run this again, it should tell us that it's trying to update that. And then we'll have to see if it does that. Yeah, this used to show the control plane node, doesn't it? So it might be a mismatch with the API and the UI, but that's fine.
But yeah, hopefully that's kind of shown that the fact that it's both complex and sort of composed of individual fairly simple. I don't want to use the word simple, but like each of these steps is not that complex in itself, but the more which things like cd into this directory and run this command in itself is the same as you building a bash script or any other kind of command, right? But then when you start chaining these things together and using the output from one as input to another, that's when you start to get the real power of this.
Absolutely. So quickly, we've got 1 minute left, but I've deleted that cluster. And this is one of the real benefits of like infrastructure as code, infrastructure kind of thing. If we run the plan again, hopefully it should realize that no longer exists and it will try and recreate it for us. But that's one of the main benefits. If you define everything using infrastructure as code, you're never going to get yourself in a state where you go, how did I create that production environment? Because so that's errored because I've got a dependency in here where it's trying to talk to the Kubernetes API endpoint. But now I've deleted the Kubernetes cluster, it's all going to fail. But that's just me being silly. Yes.
But again, that's something that you could then go and look at your code, which is currently in GitHub, and go like, oh, okay, so it's this commit that's caused this. And I now realize that this is actually a weak point. And we should strengthen this and make this pipeline not be dependent on talking to the Kubernetes API or whatever, thing that you can build resiliency, because that then again builds confidence.
Yeah, absolutely. So I'm going to stop sharing. Whoop. Go back to our faces and say thanks for watching. Any questions, you can get us on Twitter, Civo on Twitter. I think it is at Civo.
At Civo Cloud.
At Civo Cloud. The questions for this are in the, I'm going to point down, I assume the description's down below. Let us know how you get on Twitter. There's also the Civo Academy if you're interested in Kubernetes. Go to the Civo website, find out more, get involved. Thanks so much for listening, basically.
Yep. Thanks, everybody.
Goodbye.
Bye.